All right, so I'm going to go over the energy in a transverse, the energy in a transverse wave that we've been talking about in the previous example. So delta K equals 1/2 mu delta X Vy squared, obviously, because 1/2 mv squared is going to give you the delta K that you're looking for. So dk equals 1/2 mu dx vy equals 1/2 mu dx times negative a omega cosine kx minus omega t squared, which is equal to 1/2 mu dx a squared omega squared cosine squared kx minus omega t for an initial y of a sine omega kx minus omega t. So we're going to just ignore time for a second and see how much kinetic energy is in a wavelength in any given amount of time, or at time equals 0. So we integrate that from 0 to lambda, and then find its 1/2 mu a squared from 0 to lambda times 1/2 1 plus cosine 2x, because cosine squared x, or cosine squared of, let's call it u, is equal to 1/2 1 plus cosine of 2u, and cosine or sine squared u is equal to 1/2 1 minus cosine of 2u. So we integrate that, we find that, and find that the final kinetic energy over wavelength is 1/4 mu a squared omega squared times lambda. And then the potential energy at any given time integrated over a wavelength is going to be 1/2 ks times x squared, because you're talking about a spring. So that's why we're going to model this as we're going to model it as a spring with 1/2 delta m omega squared x squared uh, being equal to ks, because k omega is the square root of k over m. So we just plug that in to get ks equals m omega squared, and then uy, or u over an entire wavelength, is going to be equal to 1/4 mu a squared omega squared times lambda. So E lambda overall is 1/4 mu a squared omega squared lambda plus 1/4 mu a squared omega squared lambda is equal to 1/2 mu times a squared times omega squared lambda. And then that tells us the amount of power or the amount of energy in any wavelength of time, or any wavelength at a given time. So the way that we find the power, or how much that energy is going to affect you, so if you're listening at a loud concert, or if you're getting knocked over by a wave, or light's traveling to get you, how much power that is going to be 1/2 mu times a squared omega squared lambda over t, because it's just the energy divided by the period, because that's how much energy is going to pass in one wavelength, and it takes one period in order for the energy to pass, or for one wavelength to pass, as given by v equals lambda over t. So that is going to be what I have to say about energy. Yeah. See you in a second.